Hello, we are the group that created the Bionic Hand for our senior project, and our team consists of Sabrina Knuckles, Mark Morrison, and Christopher Villarreal. Our idea for the arm is a 3D printed model of a prosthetic arm for amputees. The reason we chose this for our senior project is because we realized that for amputees, there aren't many options out there for prosthetic arms. We know that for amputees, missing an arm can make life challenging and difficult. We are trying to give amputees a cheaper, more economic option when it comes to a prosthetic arm. Now, there are options on the market that are mechanical, but they are expensive and not everybody can afford it, even with their medical insurance. With our design, we are hoping that it can create a new opportunity for many people that are looking for this type of product. This bionic arm will be able to give amputees more limited abilities to do things with an extra arm that is standard non-mechanical prosthetic limb. Our design that we came up with consists of using EMG patches to read muscle signals and therefore be able to control the arm. The signals from the arm will be read and coded into the Arduino, which will be relaying information to the bionic arm to move the corresponding parts. With the arm, we also incorporate a temperature sensor into the arm so that the person will be able to know if something that they are touching is potentially hot. This product will be very helpful to anyone who is looking to buy a prosthetic arm that is more cost friendly. This is a short demonstration of our robotic arm, going through some of the motions and showing the capabilities. So it starts with the closed fist and works through each finger, skipping the middle for appropriate reasons, just demonstrating the movements. Now this video is a close-up shot to show the extension and reach of the fingers with more clarity due to the PLA being slightly darker and harder to capture on camera. Now the ring finger and the pinky finger are both able to close in slightly more to be able to give a better grip as well as a more natural look when the fist is fully closed. Throughout the timeline of this project, we've encountered many problems. These problems occurred in the prep phase as well as our building phase. Due to the COVID-19 pandemic, our prep phase had many unexpected delays. Parts that we ordered took longer than anticipated. We have received a couple of defective motors, and to order new ones delayed our project and testing even more. The majority of the problems and setbacks came during our building process. Our 3D printed models weren't precise the way that they were designed on the computer. Some of the prints would fail, or they would be slightly bigger or smaller due to them being printed. The quality of the prints were due to the 3D printer that we used and could possibly be improved and be more precise with a more expensive 3D printer. With these size differences in our prints, we came across many fitment issues and had a lot of sanding and filing and custom fabrication needed to be able to make the parts fit together. The designs on the computer were right and that they would fit together, but when implemented and 3D printed, they were always slightly off due to the capabilities and limitation of the printer that we used. Also, during the printing phase, we came across many failed prints, which then pushed our timeline further and further back with each failed prints. Our printing of the parts took approximately 72 hours in total. This number is if all of our prints came out perfectly the first time. So this gives you an idea of how long just the printing process is for parts that aren't even that big. During our construction, we had parts that would snap and therefore have us reprint our designs with a different density infill for our robotic hand. We would increase the density on the parts to make them stronger and more resistant to breaking, but this would also mean the parts would take longer to print and also use more filament. We tried to only strengthen the parts that would undergo the most stress and have it still be our goal to make it as cost efficient as possible. Technological problems that we ran into were with the coding of the EMG patches. The patches sometimes didn't quite always pick up the right signal consistency, and when reapplied they would slightly be different results. Another problem was with the motors and that the power supply wasn't always enough. We went through many phases to get the right necessary current and voltage needed to be able to operate the fingers individually and all together. After many test runs, we would shortly drain our power supply and have to charge or get another one to be able to keep on testing. Now, this project has taught our team many lessons. We learned that designs aren't always perfect when being implemented. So this means that no matter how much planning can go into it, the results will always be a factor of two things: your initial design and the hardware that you have at your disposal. The second thing we learned is that teamwork is very crucial and important when working on larger projects. Multiple heads are better than one and can often solve problems more quickly and effectively. This pandemic made it hard for our group to get together at times, but being able to speak remotely through apps like Zoom made problem solving and planning slightly easier. The third one is persistence is key. During this project, many things have gone wrong and not according to plan, and have had many delays due to the pandemic. But with perseverance, we were able to pull through and get this project operational. For the future of this project, we would like to incorporate our design and have it fully functioning the way we initially intentioned. With many product delays and design errors and time restrictions, the temperature sensor and the EMGs weren't fully functional and operational with our end result. And it is something that would be very beneficial and set our project apart from others that are already available. The second thing to change for the future, that would be the EMG patches. After many errors with it, we would like to find a more accurate type of patch or sensor that can give consistent results and be able to be used universally on different people. The Bionic arm is still a very promising product, but with the future implementations, I feel that it will be even better.